will start with the chapter of motion, the first chapter of physics. It's a very interesting chapter where we'll be studying about the motion and rest of an object. We'll be studying about certain terms that help us to understand the motion of an object. We'll come across two very important quantities, scalar and vector quantities, which we have already studied earlier. But here we'll be getting a detailed idea and we'll be studying it in more uh, greater knowledge. So, what is motion? A simple reply is that when object is moving, it is said to be in motion. But then, how do you interference? How do you determine whether the object is moving or not? Let's see this example. See, this is a person standing at position A. Maybe he's home. And after 5 minutes, that is at 10:05 a.m., the person is 15 meters away from his home at the bus stop. So now in this case, if we try to see the scenario, just try to understand it. What do you see? The person was at this position A at 10 a.m. and the person has changed his position to position B after 5 minutes, that is 10:05 a.m. And to do this, he has covered around 15 meters. So motion, can we say that motion has two important aspects? One, it is a change in position, and second, in a certain time period. Now see, from A to B, his position has changed. Okay, and by how much his position has changed? By 15 meters. If you compare the surrounding also, the surrounding has changed. He was at his home, now he is at bus stop. And to do this change, he has taken some time. In certain time, that is about 5 minutes. 5 minutes in this case. Isn't it that when we try to define motion, now we have a better meaning, a better definition for motion. Motion is a change in position of an object with respect to surrounding and time. So motion is a combination of two important factors. One, the change in position, and second, with certain time involved in that change. If the object is not changing its position with change in time or surrounding, that means the object is at motion, rest. So there are two important quantities, motion and rest. Now student, you will be very surprised, but let me tell you that these two things are equally important. They are called as relative term. You will find that motion of an object is determined by comparing it with the object at rest in the surrounding. Let's take an example. You're sitting in a bus, the bus is moving. When you look out of the bus, you see if the surrounding is changing. So you say that the bus is in motion. But when you look your position with your co-passenger, has it changed? Are you in motion with your co-passenger? No. That's why motion and rest are called as a relative term. Most of the motion are determined because we are able to compare it with the surrounding. If we cannot compare the motion, we may not be able to determine whether the object is moving or not. For example, the building in which you are living, your school, everything is located on this earth. And if I ask you whether they are in motion, do you think they are in motion? The reply is no, they are at rest. Why? Because when we compare it with our surrounding, their position has not changed. Now for one moment, just think about the earth. Do you think the earth is at rest? You have studied that earth is rotating around the sun in its orbit. Right? So now earth is in motion or at rest? Earth is continuously moving around the sun. But then, when we compare the position of the building with its surrounding, it has not changed. But then we know that Earth is continuously in motion. Isn't it? The building which is located on this Earth is also in motion. Both this example of passenger in bus and the building or the earth is termed as a complex motion. And that is why I said that motion and rest are relative terms. Had it been that there were objects in the sky with which you could have compared the position of earth, you would have seen that it changes continuously. As a result, we could have seen the motion of the earth. But since there is nothing in the sky, we are not able to compare, and we'd say that there is no change in the position of the earth or the building. These are examples of complex motion. So earth, bus, passenger, as I told you, they are complex motion. Why they are called as complex motion? Because you are not able to compare it properly. There is no object at rest, or when you are comparing it with the system, you can see there is a change. But when you are comparing with the surrounding, you find that there is no change. For example, the bus, when we compare it with the surrounding, we find that the position of the bus is changing. But then at the same time, when we compare the position of the passengers, there is no change. Similarly, the buildings on the earth's surface, when you compare it with the surrounding, you'll find that they appear to be at rest, but the whole earth itself is in motion. So they are also moving along with the earth. Now, these are examples of complex motion. And as I told you, the reason is that when you are not able to compare the motion with object at rest. Okay, so that's why motion and rest are relative term and a very important term to be understood. Without object at rest in the surrounding, you may not be able to determine the motion of an object. Now, there are two types of motion: uniform and non-uniform motion. I'll try to make you understand with the help of example. For example, I'm taking example of two object A and object B. Time will take same duration of time because time does not changes, it changes uniformly. So let's consider we are comparing two objects A and B. This starts from 0 second, after 10 second, 20 second, 30 second, and so on. At 0 second, the position of object A is 0 meter, position of B is also 0 meter. Now after 10 second, A has covered 20 meters, B has covered 30 meters. After 20 second, now A has covered 40 meters, whereas B has covered 45 meters. Again, A has covered 60 meters, B has covered, suppose, 55 meters. 40 second. If I ask you, what will be the distance covered by A? Can we predict it looking at this train? Right? Yes. We see that it covers 20 meters in every 10 seconds. So what will be the distance in 40 seconds? It will be 80 meters. Now when you are talking about object B, can you predict it? No. Why? This is a non-uniform motion. Remember, non uniform motion. Whereas here it's a uniform motion. See, it is covering equal distance in equal time interval. Every 10 seconds, it has covered a distance of 20 meters. Whereas in case of B, do you find equal distance being covered in equal time interval? No. So this is an example of non-uniform motion. So what is uniform motion? When it covers equal distance in equal time interval. Whereas unequal distance in equal time interval. I'm sorry. So, uniform motion means when an object covers equal distance in equal time interval. Whereas on the other hand, if an object covers unequal distance in equal time interval, then it is said as non-uniform motion. Throughout this chapter, for the purpose of simplicity and to understand it properly, we'll be using the concept of uniform motion every now and then. Whereas non-uniform motion is not that it will not study about it, but it is quite difficult at your standard. So you'll be studying about it in more details in higher classes. Now, uniform motion gives us a uniform speed. So first we'll study about speed or the rate of change in motion. Before going to the rate of change in motion or speed, we'll try to understand two important quantities: scalar quantity and vector quantity. Scalar quantity vector quantity. Scalar quantity are the one which has got only magnitude, means only quantity or measurement, but no direction is involved. Vector quantity, on the other hand, it has both magnitude and direction. That means it has got measurement as well as a direction. For example, if I say that I'm walking at a speed of 20 meters per second, where? Does it specify? No. That means I have got only measurement, that is, my speed is given. What is the speed? 20 meter per second. I am walking with a speed of 20 meter per second. Did it say anything about direction? No. So it has got magnitude. We say such quantities as magnitude, measurement. Now, if I say that I'm moving at a speed of speed of 20 meter per second toward east. Please don't mind it. Marco is not working well. Okay, thank God. Toward east from west. Isn't it? Here you have both magnitude and direction. So this is an example of a vector quantity. Whereas when there is only magnitude, no direction, that is an example of a scalar quantity. Scalar quantity, we are more familiar with scalar quantity like mass, speed, time. These are all example of a scalar quantity. Whereas when it comes to vector quantity, you can't say speed with direction is a vector quantity. Speed with direction is a vector quantity. Yes, but then what is the unique name for it? It's called as velocity. Distance traveled, okay, in any direction, that is a scalar quantity. Distance traveled or covered in a particular direction, that is vector quantity. Again, for distance in a particular direction, we have a unique name, displacement. Acceleration, velocity, displacement, gravitational pull or gravitational force, all these are example of a vector quantity which has direction as well as measurement. Whereas quantities like speed, distance, time, mass, these are called as a scalar quantity because they do not have any specific direction. Direction does not play any important role in this case. Now, in this chapter, why am I talking about scalar quantity and vector quantity? Because you'll be coming across the quantities which are like velocity, acceleration, which are a vector quantity. And remember one important thing, scalar quantity can never be negative. Vector quantity can be negative or even zero. I'll give you an example. I said that scalar quantity means it has measurement. Vector quantity means it has both measurement and direction. Now, what is the gravitational pull? The direction of gravitational pull. Isn't it? Earth pulls all the object towards its center, downward. Right? If I am moving an object upward, this is against the direction of gravity. Now, what you are going to write it? The object is moving against the direction of gravity? No. If it is a vector quantity, you just put a sign negative. G represents acceleration due to gravity, that is the force with which object is pulled toward the earth. So if it is moving away from the earth, it is again moving with the same force. So see, G is negative and that itself tells a lot. We understood that yes, the object is moving against the direction of gravity. As a result, the negative sign is implemented. So vector quantities can be negative, it can be zero. Scalar quantities are never zero or negative. They are always positive value. So now moving to the vector quantity and scale. Moving away from the vector quantity and scalar quantity, let's try to understand and implement it in this chapter of motion. So I'll give you an example. You and your best friend, both of you live at a different place and you got a chance to do bicycling. So you and your best friend wanted to bicycle till the school to see the condition of the school during this lockdown. So now you decided that we'll meet at 10 a.m. exactly to the school, and you came over there at 9:50. Your friend came over there at 10:05. That means 10 past 5. So you have reached school at 9:50 a.m. You started bicycling at 9:30 a.m. Remember, you started at 9:30, you reached school at 9:50 a.m. And your house being close to the school, you have covered a distance of, let's say, 800 meters. You stay somewhere in Chobar. So in 20 minutes time, you have covered 800 meters. Your friend, he stays slightly far from the school. He started his journey at suppose 9:45 and he reached the school by 10:05 a.m. So how much time he has taken? He has also taken 20 minutes, and he says that he has covered approximately around let's say that you have covered slightly more distance, okay, 1800 meters, and your friend has covered a distance of, okay, dear students, let's make a small change over here. The change will be, instead of 30, let's make it 35. So the time is 15 minutes, right? Both the friends are trying to argue. He says, see, I came faster. He says, I came faster. In one go, you can say that, yeah, this time looks smaller and distance look bigger. Whereas here also, the same thing goes. So, the quantity or the motion is very well defined by a quantity called as speed. Speed helps us to determine whether the object is moving faster or slower. So what is speed? Speed is defined as distance covered in unit time. Remember, unit time means in 1 minute or 1 second. Now the SI unit of distance is meter and the SI unit of time is second. So speed is defined as or measured in meter per second. If you want to find the speed, see here the time is given 15 minutes. So if you convert it, that becomes 15 into 60, 900 seconds. And the distance covered is 1800 meters. So his speed is 1800 divided by 900, that is equal to 2 meters per second. Similarly, his distance again, it says 2 kilometers, 20 minutes. If you convert the time and the distance, I'll rub the board over here. So I said that his time is 20 minutes, that is equal to 20 into 60 second, and that is 1200 seconds. And distance covered is 2 kilometers, which again is equal to 2000 meters. So his speed will be 2000 meters divided by 1200 seconds ten by 6 approximately 1.67 meters per second. So you see, now it becomes so easy for us to compare whose speed was, or who was moving faster and who is moving slower. So speed is a very important factor in case of motion, because speed helps us to compare the motion between an object. Speed tells us whether an object is moving faster or slow, and speed is measured in unit called as meter per second when the distance is small. Of course, if the distance is too big, then we use a bigger unit of speed called as kilometer per hour. And how do we define speed? For speed, we say that distance covered in unit time is called as speed of an object. If the speed is in a particular direction, if the speed is in a particular direction, then it becomes a vector quantity. We call it as velocity. Now, if the speed is in particular direction, that means distance covered is also in a particular direction. So that quantity is called as displacement. So how we can define velocity? For velocity, we can say that displacement in unit time is called as velocity of an object. Displacement in a unit time is called as velocity of an object. The unit of velocity is same as the speed, that is meter per second. Only thing is that velocity depends upon direction. If the direction changes, velocity can become negative or it can be even zero. I'll give you an example. Displacement, as I told you, displacement is the shortest distance covered between starting point and finishing point. Suppose if I'm moving in a circular track, after one circle, if I come back to the same starting point, now what will be the displacement? Isn't it that the displacement is zero? If the displacement is zero, then do you think this object has a velocity? I said that an object is moving in a circular track. It starts from A, goes all around the track and comes back to A. So what is the displacement of the object? Isn't it displacement is zero? Do you think distance is also zero? No. It has moved and it has covered some distance. But displacement is zero because displacement means the shortest distance between starting point and finishing point. Since it is coming back to the same starting point, so displacement becomes zero. So in this case, you'll find that the velocity of the object is 0 meter per second. But if you ask about distance covered, it has some distance because it has moved around that circular track. And since there is distance covered by the object and it takes some time to cover that distance, the speed is never zero. So this is another important way to understand how scalar quantity and vector quantity are different. Scalar quantity can never be zero. Like in this case, the object has speed, but the object has no velocity. That is how we can understand a scalar quantity and a vector quantity, and two important quantities like speed and velocity, remaining in some other class.